morning. Happy Thursday. Welcome to the end of our class week. I was told last week that, oh man, you were really waiting for the end of the week to come because you said it was the last day on Thursday. I say it's the last day on Thursday because it's our last day of broadcasting on Thursdays. Yes, I understand Fridays still count and Friday's still part of a work day and we are still here doing our thing. But it is Thursdays that our classes are finished for the week. Fridays are for you to get caught up on class assignments. So, tomorrow still counts. Tomorrow's still a day. Tomorrow I am still here in the office, willing to help in any way I can with any questions you might have about the course material. But you don't need to tune in at 10 a.m. because there will be no class being aired. That's it. We are at the end of our 7th week. Today we're going to jump into lesson 17. It is a 2-part class. Lesson 17 is going to take us 2 days, and I don't really like splitting it up over the weekend, but in order to get everything in on time, it's just going to have to be that way. Today we're going to cover lesson 17.1. When we come back on Monday, I'll do lesson 17.2. Then we've got lesson 18, 19, finishing with lesson 20 next Thursday. And that is all of the curriculum material. That last week, our week 9, is going to be for review. We will go back through Unit 1, Unit 2, Unit 3, and Unit 4 so that you're feeling confident for your exam. You will have a refresher of what we did way back here on September 2nd when we first started the term. Remember that just because we're coming to the end of our term doesn't mean that you can't keep submitting work. It's just that after October 31st, we switch gears and this whole radio Zoom timetable schedule that is in our course calendar and I have here on the board in front of me that says at 10 a.m. I teach this MAP4C course, followed by PLAR at 11, grade 12 English at 2 o'clock, etc., etc. That schedule is going to change after October 31st. We will be switching to our term 1B term, and new courses will be presented then. Next term, come the second week of November, instead of teaching this grade 12 Foundations for College Mathematics course, I actually step in and teach the co-op, the cooperative education material. But you can still get this course work completed, however long it takes. Remember that when you finish a lesson, submit a lesson, and for every lesson that you turn in, your name gets entered into our term end draw. If you submit all 20 lessons come October 31st and you complete the exam, your name will have been entered into the draw 21 times. If you're successful in your course material and on your exam and you get the credit, then your name gets entered for a second prize. You have the chance of getting your name put into 2 different draws if you complete all your work and obtain the credit. So keep that in mind. It's a wonderful added bonus. Complete lessons, submit your work, get your name entered for one of, well, 2 prizes if you do the coursework and complete the course to get the credit. A little plug there. Let's look at moving forward. We talked a lot about perimeter, circumference, area, surface area Yesterday in lesson 16, we talked about volume. We now know volume is the amount of space occupied by a three-dimensional object. Area is measured in squared units, but volume is always measured in cubed units. When you are looking at finding the volume of an object, be sure to identify the sides and their lengths. I do recognize that we did not get through all of the formulas to practice. We went through what they all were. We saw examples of how to do it, but we did not get to practice our own examples. And we will do that over week 9 when we're looking at our review. If you don't want to wait until then, you can always go to your support questions in your IL booklet and practice those questions to see if you're on the right track. The answers are at the back of the unit, and then when you're feeling confident, you can move on to the key questions. If you're not confident and you don't want to wait until week 9, please don't hesitate to reach out to see how to do those. I will happily help. Today we are switching gears. Lesson 17 is about trigonometric ratios. We will explore trigonometric ratios and better understand what they are, as well as how and when to calculate them. Now, last school year, when I taught this course, I got really excited about trigonometric ratios, and I said over the air I was about to nerd out. We're going to be doing trigonometry, and I got a message that said, "Why do you use the words nerd out? Everyone's going to tune out and change the channel. Don't go full nerd when you talk about trigonometry." So I'm trying my best to not get too excited today, but I love trigonometry. And I want to say this because I want to acknowledge that not all parts of this course will be your favorite. There are, I'm sure, some mistakes that I've made as I've been teaching, because there are days that you're tired, there are days when you're not in the mood, there are concepts that just aren't your favorite and you don't give it your 100% or all of your attention. And I'm human too, and I recognize that. So I want you to know that I understand some lessons aren't your forte. They're not your favorite, they're not your strength, but that we can still work together to help one another out to be successful in this course. If I haven't said it enough, I do want to state that you can always resubmit work if you're not happy with your grade. If you got a 64 and you were really hoping for at least a 70, you can always try your hand again. Read the feedback that I've written. See where you went wrong and try your hand at it again, and you can resubmit. That is more than okay. All right. We're moving on to trigonometry. I stinkin' love it. You might not, and that's okay. Together we will get through, and I hope to get you a little bit more excited about trigonometry if you're not a fan. By the end of these 2 classes, I hope to have converted you. Today's learning goals are that we will be able to recognize and label parts of a right triangle. We will understand how and when to use the trigonometric ratios to find unknown sides of a right triangle. We're going to use trigonometry to find unknown interior angles of a right triangle as well. Keywords that you're going to need to know that you might not remember. It might have been a while since you used some of this vocabulary. So let's refresh. A right angle is simply a 90-degree angle. So in our learning goals, when we're talking about finding unknown sides of a right triangle and using trigonometry to find unknown interior angles of a right triangle, We're talking about a triangle that has a right angle, and that's simply an angle that is 90 degrees. I will break this down and get into it more, but here, if we have a triangle, if it has 90 degrees, it's acknowledged or shown through this little L that is making a perfect square. When you have this box in the corner, that means it's a right angle. We've worked a lot on these hash marks. So if we have a parallelogram, we know that if the sides are the same, there's just a straight line through them. That means that their length is the same. If they're parallel, it means that we have these arrows, hash marks, that are facing the same way. Now, if we have a right angle, so maybe we have a triangle, a square, a rectangle, whatever it may be, if it has this little box in the corner, that means that it is a right angle. It's a perfect 90 degrees. So that's the right angle. A right triangle is a triangle with one right angle. So that is one of the angles is going to be a 90 degrees. An acute angle is an angle between 0 and 90 degrees. That's a small angle. So here, if we use this triangle that I showed on the board, an acute angle is less than 90 degrees. It's small, it's cute, it's a cute angle. An obtuse angle is if we have an angle between 90 degrees and 180 degrees. So it is, let's do it like this maybe. Here we go. It is a larger, it's open, it's bigger, it's obtuse, it's greater than 90 degrees. It's between 90 degrees and 180 degrees. So acute is less than 90 degrees, obtuse is greater than 90 degrees. To help you be successful in trigonometry, it is important to be mindful of Pythagorean theorem. Pythagorean theorem is what we need for right triangles. For any right triangle, the area of the square on the hypotenuse is equal to the sum of the areas of the squares on the other two sides. So on the board in front of me, I have a right triangle, ABC, with the hypotenuse being C. What all of these words mean is, if we're looking at the area of the square on the hypotenuse, that would be C squared. It's equal to the sum of the areas of the squares on the other two sides. So that means side A and side B are squared, and together they will equal the square of C. So Pythagorean theorem applies to right triangles and is simply C squared equals A squared plus B squared. Now you can apply this to find the side of a triangle, which is why it's important to know Pythagorean theorem, because you can use it when we are doing trigonometry to help us identify side length, to find angles, you'll see how it all comes together. But I wanted to show that your hypotenuse is the longest side. It's usually identified as side C. And when you want to find the length of the side, we would do the opposite operation, which is the square root. So if you want to just find what C squared is, but you just want the length of C, you will square root it. And we're going to get through all of this, but I wanted to give this precursor because a lot of people work better when they see the big picture and then they can hone in on how to get there once they zoom out a bit. The next important thing that you're going to need to know before we move forward is the word trigonometry means measurement of a triangle. So this is going to work if we have a triangle. When first learning about trigonometric ratios, you will be working in degree mode. So if you have a scientific calculator, more often than not, it's already in degree mode. No matter the calculator you have, whether it's a Casio or a Sharp, whatever it may be, at the top of your screen, once it's turned on, you'll either see a little DEG, sometimes it's just a D, and it's telling you that you're working in degree mode. If you see an R or a G, or maybe it says RAD or GRA, then we're either in radians or grade. Gradient if we see R or G. We only want the D, we want degree. Since the calculator defaults to radian mode, be sure to set your graphing calculator to degree mode. Usually people work in degree mode, so they've already changed it to degree. If you received a calculator from school, if you received it from the Learning Center, it's most likely already changed to degree mode. But if not, look for that. It needs to be in degree mode. And if you don't know how to do that, sometimes there's a button on your calculator. Now, unfortunately, the picture that I have on the board is really blurry and you can't see. Sometimes there's a button that says mode. Sometimes there's a button that says DRG, and it stands for degree, radian, and grade. If you see that, you can push that button. It will either come up degree, rad, or gra, and you want deg because that's degree. If you've got mode, you might have to switch through. Sometimes you have to push. It'll bring up this screen that says degree 1 or deg 1, rad 2, gra 3. We want degree, so you would push 1. If you're not sure, you can always Google it. YouTube is fantastic for showing you can type in the calculator that you have and find out how to put it into degree mode. So we're set up, we have the tools that we need to be successful. Let's go to page 12 of Unit 4, where we are going to learn first about the hypotenuse. The side that is opposite the right angle in a right triangle is your hypotenuse. Remember, you can always distinguish the right angle because it forms that box. That means that is a right angle, which means it is 90 degrees. Opposite that right angle is the hypotenuse. The hypotenuse is always the longest side, and it's always opposite the right angle, and we usually label that side C. Side C is the hypotenuse. That's how it works in Pythagorean theorem. The other sides are also known as legs, and it doesn't matter if you label it A or B or vice versa. We are going to use Pythagorean theorem to determine the unknown length. We want to practice becoming familiar with Pythagorean theorem so that we can be successful in the future examples we're going to come across, that we're going to work towards, so that we are familiar and can work through. Remember, we want that base. We need to build that foundation before we move forward. So here we have triangle ABC, and you always call a triangle 3 letters to distinguish which angle. So here you say triangle, and you're actually drawing a triangle, A, B, C, because we have A, we have B, and we have C. Angles are always capitalized, so angle A is the capital letter A, angle B is the capital letter B, and angle C is the capital letter C. Its opposite side, the side opposite to it, is the lowercase. So opposite angle B is side B, which is lowercase b. Opposite angle A, which is uppercase A. Opposite that, we're going to have side A in lowercase a. And then angle, capital letter C, angle C, opposite that is side C, and it's lowercase. Here we have triangle ABC. We want to determine the unknown length. So it shows us here, now that we've labeled our legs or labeled our sides, side A is 15 feet, or leg A, C is 21 feet, and then we have B. And we want to know, what is the length of B? Well, my friends, we get to use Pythagorean theorem. Remember the formula. Pythagorean theorem is a squared plus b squared equals c squared. Just like we've been doing this whole course, we're going to plug in what we know. We're going to substitute what we know into our formula. So A, we've labeled A as 15. We don't know B, but we do know that C is 21. So we're just plugging what we know into our formula. So it's 15 squared plus b squared equals c squared, which is 21 squared. Now, we want to get b by itself. We need to find out what is b. Right now, b is attached, so to speak, to our 15 squared. It's not attached in the normal way. I think it seems like we've had them attached through multiplication. All of the other times we've had to eliminate it. But here it's attached through, it's actually a positive 15. There's no plus in front, but we know it's positive. If there's nothing in front, it's either it is positive or it will have a positive. If there's a negative in front, it's negative. So here we have a plus 15. We need to get rid of it because we want to get b by itself. Like we always do, we do the opposite operation. So we're going to subtract 15 squared, so it cancels out, but whatever we do to one side, we have to do to the other. So we have to subtract 15 squared from the other side. So that leaves us with b squared equals 21 squared minus 15 squared. We can solve 21 squared minus 15 squared. Now, it's up to you if you want to first find out what is 21 squared. And you can write that in if you want. So we can say b squared equals 21 squared is 442. And then we can find 15 squared is 200. Oh, there we go, 42. 15 squared is 225. And then we can see what is 442 minus 225. We get 217. If you want to just plug it into your calculator, you can most definitely say 21 squared minus 15 squared, and you get 216 because of the accuracy of its calculations, so to speak. So that's why the way that you write it, it's important to show so that we know it's not just like a calculation error or you accidentally wrote the wrong thing. So if I'm writing it all the way out and solving for what is 21 squared, what is 15 squared, and what if I subtract the two of them, I would get either, oh, no. It's because I wrote 442, but it's actually 441. So, yeah, sometimes everything that I just said was right, but sometimes I'm just simply wrong. And yeah, it can be because of the decimal places, but here I just wrote the wrong number. So it's 441 minus 225. You get 216. There we go. So 216, no matter which way you calculate it. So b squared equals 216. Now, we want to get b by itself. Right now it's attached to the exponent squared. We have to do the opposite operation, which is the square root. We're going to find the square root. That cancels out the squared, leaving us with just b, but whatever we do to one side, we have to do to the other. So now we're left with just b equals the square root of 216. We get b equals 14, let's say, decimal 7 feet. So side b is 14 decimal 7 feet. Now, you can also rearrange Pythagorean theorem to hone in on just what it is that you want. Pythagorean theorem says a squared plus b squared equals c squared. So we went through, and I'm going to use my laser pointer so you can see here. We went through and we did this elimination of a squared. We did the opposite operation, canceled it out, moved it to the other side so that we were left with just b squared on the left of our equal sign. You can do this step of canceling out the 15, moving the 15 squared to the other side, or we can rearrange the formula right from the get-go. Instead of saying a squared plus b squared equals c squared, we can just take this formula, and I'm going to see if it will let me. No, it moves the whole thing. We can say b squared equals c squared minus a squared, which is essentially what we did in this step, but we're just writing it right off the hop, so to speak, so that we don't have to do that step with our numbers plugging in. We can just move it over. The other thing that you can do, which brings you right to the end, gives you right to our last step here of, we can say that if you want to find just b, you would have to do the square root of b squared to find the square root of c squared minus a squared, and that would give you just b. So if you want to do all of that changing around to begin with, you could simply start this question with square root of b squared equals the square root of c squared minus a squared. And then you just plug it right in. We would say the square root of b squared equals square root of, we know c is 21 squared, minus a is 15 squared, b equals, and all you have to do in your scientific calculator is type in the 21 squared minus 15 squared to get b equals 14 decimal 7. So you're doing the work, so to speak, of moving things around. You're just moving things around before you plug in the numbers. I should also note here on Desmos, see how we have degrees and radians? It defaulted to degrees, but if we needed to work in radians, you change to radians. Degrees is what we need for trigonometry. It's highlighted in blue, so that's good. That's where we are. That's what we want. Okay, we have a better idea of moving things around, and here's a graphic that shows this is how we can get just what we want. You can keep this graphic as a cheat sheet if you want. If you just need to find side B, you're saying it's the square root of c squared minus a squared, which is exactly what we did. Let's jump into the meat and potatoes. Primary trigonometric ratios. When we are talking primary trigonometric ratios, we are speaking of sine, cosine, and tangent. The 6 trigonometric ratios are, we have sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Now, these are the main ones that we're going to be looking at. This is all we need to know for today. To help us remember that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent, these mathematicians have come up with another acronym to help us remember through SOHCAHTOA. Yep, almost as cool as BEDMAS. Nay, cooler. SOHCAHTOA. When we need to think of our trigonometric ratios, we can remember SOHCAHTOA. The SOH is SOH. Sine equals opposite over hypotenuse. Ka is cosine is equal to adjacent over hypotenuse, and TOA is tangent is equal to opposite over adjacent. So when you hear trigonometry, you're thinking of your ratios, remember SOHCAHTOA. For acute angle A in triangle ABC, we can use sine A. Remember, if it's that uppercase, we're talking about angle. So uppercase always means angle, lowercase means side. So for sine A, it is the length of side opposite angle A, which is always our lowercase a, and then divided by the length of the hypotenuse, and hypotenuse is always c. So sine A equals little a, or side A, divided by c, which is hypotenuse. Cosine is equal to the length of side adjacent to angle A. So adjacent to, now, did I have a cool, no, which means I get to make my own diagram. Here we go. Let's say we have triangle ABC. Now, one of these has to be a right angle. So let me try to be a little bit more. There we go. Okay, we have a right angle. So we have A, B, C. Our angles are in uppercase. Across from angle A is side A. Across from angle B is side B. And across from our right angle, or angle C, is side C, which is, everything's frozen, hopefully it catches up soon. C, there we go, is our hypotenuse. Our hypotenuse is always that longest side, and it's opposite the right angle. So that's the easiest one to identify. That's the easiest one to put in first if you have to, so to speak. whatever's across from the right angle is the hypotenuse. So when we are looking at sine A, we're talking about this angle, angle A. Opposite side angle A is the lowercase a, but we also call that opposite. If we need to use the trigonometric ratio cosine, cosine A says that we have the length of the side adjacent to angle A. Adjacent is beside. So if you see on the board, I have triangle ABC. I'm looking at my angle A here. Opposite angle A is side A, which is known as our opposite. And then we have two sides that are beside. We have side B is beside and side C is beside. Now side C is the hypotenuse. It's already labeled. So that leaves side B as the adjacent. It's beside. It's adjacent to. It's next to. So side B is the adjacent side. Side A is the opposite side. And side C is the hypotenuse. So you need to be able to know how to label your sides so that you can properly input or substitute for your trigonometric ratio. So when you need to find cosine, it's the length of the side adjacent to angle A, that's our side B, and the length of the hypotenuse. Lastly, tangent is the length of side opposite to angle A, so that's our opposite, that's A, or the opposite, because remember, sa, ka, toa. Toa is tangent, opposite over adjacent. That's how we remember our trigonometric ratios. Are you ready to practice, team? Let's just practice labeling. We just want to label so that we know we're on the right track and we will be ready to input when we need to. For each triangle, name each side in two different ways. We have to label the hypotenuse in two different ways. When you are given a simple diagram, so this is triangle PRS, because we have P, R, and S. So this is triangle PRS. Whenever you see this curved mark, that's telling you what angle we're working with or which angle we're working off of. When you see that curved mark, that is like a spotlight highlighting the angle that we're working on. So here in our triangle PRS, our highlighted angle is angle P. Then we see the little right angle marked and identified with our box. So the right angle is angle S. When you see those two, it's giving you so much information. Seems pretty goofy. All we did was put three little marks on a triangle, a little L, and a curve, and that's telling us a lot of information. Now that we know which is our highlighted angle and where our right angle is, we can easily name the hypotenuse. Hypotenuse is always across from the right angle. That is our hypotenuse. Now, it's asking us to name each side in two different ways. It's telling us, where's the hypotenuse? Well, we could say, yes, it's across from the right angle, but how do we name that? What you can do is you can say the hypotenuse is, we can say side S. Remember, it's just lowercase s. That's telling us the side. We see that across from angle S, which is our right angle, is side S. So the hypotenuse is S, or we have to name it in two ways. We can also say that it is line, the line connecting angle R to angle P. That line that connects angle R to angle P is also the hypotenuse. Rather than saying the line connecting blah, 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 no. We're going to say capital R, capital P, P with a line on top. That is how you say line RP. Pretty easy, hey? On one hand, it's really nice how mathematicians don't like writing because it makes it really easy for the rest of us too. So the hypotenuse is side S or line RP. All right, the next one says, name the side opposite the marked angle. So again, we need to look for where's that marked angle. That marked angle is that curve, so it's angle P. The side opposite. Well, opposite means directly across from the marked angle. So our opposite side is lowercase p, or we can also call it line RS. So RS with the line over top. Then it wants us to name the adjacent side to the marked angle. Marked angle is P. The adjacent side, so that's the one beside it. We have two sides beside. We know that S is our hypotenuse, so that leaves R. So lowercase r, side R, or it's line connecting angle S to angle P. So we can say SP with a line on top. The hypotenuse side is side S or line RP. The opposite side is side P or line RS. And then that leaves the adjacent side. Adjacent means beside, next to. That leaves side R or line SP. Perfect. We're going to try one more. This time we're going to use triangle KLM. In triangle KLM, if you want, you can, if you're watching the recording of this, you can pause this right now and see if you can identify the hypotenuse, the opposite side, and the adjacent side. And then when you're ready, press play and see if you got it right. Or see if I got it right. If my brain's not working super well today and you need to call me out, please do so. Here we go. For each triangle, name each side in two different ways. The hypotenuse is always opposite the right angle. So that's going to be side K or line LM. Line LM. Opposite. See how we didn't even really need to identify the marked angle for the hypotenuse? It's the easiest one to do. Now we need to look at the marked angle. So we look for that curve. Our highlighted spotlight angle is angle M. So now we find what's opposite angle M, side M, or line KL. And that leaves us with the adjacent side. The adjacent side is the side next to our marked angle. It can't be K because that's our hypotenuse. M is opposite, so that leaves side L. We can do L so you know what it is. L or line KL. m. Oh, everything just erased. Not sure why everything just erased. Can I bring that back? There. That was weird. So our opposite side is side M. The adjacent side is L, and the hypotenuse is K. Write each trigonometric ratio as a ratio of sides. Now we're going to practice putting it together with our sine, cosine, and tangent. This is how we're going to practice reading which ratio to use and which side to use. Remember, we need to keep in mind when we're doing trigonometric ratios, not BEDMAS. BEDMAS is for order of operations. We need SACATOA. SACATOA. And with that, we will be able to know which one we're using. So the first one says, write each trigonometric ratio as a ratio of sides for sine A. When I need sine, I'm using the first part of our acronym SACATOA. We're looking at SA. So that sine equals opposite over hypotenuse. Using my triangle ABC, what is my opposite? When I'm saying sine A, I'm highlighting that angle A. That's my angle in the spotlight. So opposite angle A is going to be side A, which is lowercase a. And my hypotenuse, always across from my right angle, and it's lowercase c. So sine A equals A over C equals opposite over hypotenuse. Or we know how to write it another way, we just practice. Sine A equals side A is line BC. BC over C is line AB. Line AB. So you can write the trigonometric ratio as a ratio of sides as opposite over hypotenuse, A over C, or line BC over line AB. Let's practice cosine. Cosine A, we're going to use CA from our SACATOA acronym, which means that we need to do adjacent over hypotenuse. So if we're looking at angle A, it's still angle A. We're just using cosine now instead. We don't need to know the opposite. What we need to know is hypotenuse and adjacent. So the hypotenuse is the same. Hypotenuse is C. And now adjacent is beside. That would be line B. That's adjacent, opposite, and hypotenuse. So if I'm looking at cosine A, I need adjacent, which is side B, over hypotenuse, which is side C. And I can also write that as cosine A equals line AC over line AB. AC over AB. What if I change it to cosine B? If I change it to cosine B, B is now my marked angle, my highlighted angle, the angle in the spotlight. I'm still using CA, which is adjacent over hypotenuse. That doesn't change, but my side does. Hypotenuse is still the same. Hypotenuse is always opposite that right angle. So it's going to be line C. And adjacent now is going to be beside, which is line A. So we can say line BC over line AB. And I told you I get so excited with trigonometric ratios, I completely lost track of time. That's all the time we have for today. I know the suspense is going to kill you. How do we do tan? You'll have to wait over the long, not really long weekend. But